everybody. I am Kjerstin Thorson from Michigan State University, and I'm here today with my colleague CK Pak to talk to you about auditing algorithms with donated data. I wanted to say thank you to Jakob for organizing this panel and to all of you for tuning in. We wish you were seeing you in person in Australia. Hope you are all doing well. So I'm just going to take a few minutes here at the very beginning to talk about our project and auditing as open science, and then I'll turn it over to CK to walk you through the other elements of the presentation. So I'm not going to spend a lot of time here, but as many of you know, of course, there's a great and growing literature on auditing algorithms, essentially trying to untangle the mechanics and the consequences of algorithmic decision-making for the allocation of resources of various kind, and in particular to read algorithmic systems for the possibility of bias, which is really at the core of the project that we're going to talk to you about here today. And in essence, our research team has for a while been interested in the ways in which algorithms that sort people out, that is, sort people and classify people in terms of what their interests are, what are the ways in which those algorithmic decisions have consequences for what kinds of content people see on social media? And so specifically, how do algorithmic classification systems have a role to play in shaping whether or not any given individual is exposed to news and political content on social media platforms? So we've been studying this for a while, and it's not exactly an easy thing to do, as it always is with auditing algorithms. And of course, we could have tried to rely on access to data from platform companies as one route to study this. But as, of course, you know, for some good reasons and some not so good reasons, platforms are very reluctant to share individual level exposure data. So it's very difficult for us to get data about what people specifically saw on platforms. On the other hand, you could, of course, think about devising a tracking study in order to see what kinds of news and political content people are actually exposed to. And of course, we'll hear more about that, I think, in our panel today. And tracking studies have their own challenges in terms of not only cost, but participation and all sorts of things that I'm sure you are familiar with. But in our case, they also don't allow us to go sort of behind the scenes and try to tease out what the role of algorithmic decision-making is in contributing to who sees news and politics on social media and who does not. So the project we're going to talk about today, we really devised to sort of solve this problem for ourselves, and at the same time, it turns out that many others of you were engaged in data donation projects as well. I think there's a real flowering of interest in this area, which hopefully will produce some good conversations around this panel in particular. So in our project, we combine a survey of US young adults with data donation. And we do so in order to ask the question, how does Facebook inscribe news and political interest into data? That is, how do they translate the things that you're interested in and the ways in which you communicate those interests through clicking around the platform into some sort of a classification system that says, hey, this person is interested in news, or this person is interested in politics. And then in turn, how does that algorithmic classification shape news exposure? And does it do so more so for some kinds of people than other kinds of people? For lots more about the specific method that we've devised, you can see the citation that's listed there from the article from one of the first data collections we did that came out last year. And we've done several rounds of this data collection. But the one we're going to talk about today is a national sample of 18 to 35-year-olds collected in 2018. And what we want to do with these data is combine what we learned from the data donation about the algorithmic classification system with survey measures of things like self-reported interest in news and politics and news exposure. And I think what's really powerful about this design for us and for the methodological pieces that we're going to talk about today is that we have a fairly substantial number of people who filled out the survey, and then we have the subset of them that donated. And that gives us a lot of leverage to sort of deeply explore the differences and similarities between donators and non-donators for this specific kind of donation project. So what we're going to focus on today is walking through the methodological challenges and potential solutions that emerge from this type of approach. So we'll talk first about different kinds of selection bias, that is, differences between the people who are and are not willing to donate their data, what produces those differences, and to what extent are they consequential for the sorts of theoretical relationships that we want to study in this project. Second, we'll talk about the large P, small n problem, or our particular version of it, which is we have a relatively small number of people who are willing to donate their data, but about each of those people, we have a fairly substantial amount of classification keywords associated with their count. And then finally, we'll talk about the challenge of data sparsity. I think there's a lot of ways in which studies of news exposure and political content exposure in particular deal with problems of sparse data. That is, in terms of sort of the ways in which our favorite behaviors like news use are fairly niche behaviors for a whole lot of people. But in our case, we're going to talk about sparsity in terms of the tremendous amount of diversity in the number of keywords that people have associated with their accounts, even when we're looking just solely at news-related keywords or politics-related keywords. So with that, I will warn you that we perhaps raise more questions than we end up answering, but we're very excited about the richness of these investigations. And with that, I will turn it over to CK. Thanks.
Hi, I'm CK. I'm going to talk about the statistical methods that are designed to tackle the methodological hurdles Kjerstin just talked about. The first one is a statistical correction method for selection bias. So data donators might have different characteristics from those who opt out. The recent PLQ paper found several factors that are known to be correlated with research participation for tracking studies. So to compare our result with the previous literature, one might ask a question, the privacy concerns matter. So our answer is kind of. However, there are many other characteristics with larger differences. And another question would be the socio-demographic variables matter. Our answer is not so much. This implies that the statistical correction with socio-demographic central weighting method might not be super effective. And more importantly, substantive variables of academic interest matter more, such as reliance on Facebook for news and activities on Facebook, etc. But the more fundamental problem, the question that we have is, does all this matter for analysis? Okay, because social scientists might not be interested in each variable's absolute level, but more interested in relationships of the variables. So we might want to also see another type of sample bias, bias on relationships. So these two heat maps visualize the correlations between all possible pairs of variables. Left panel being correlations from all sample, and right being from donators only. In the left panel, most of the variables are positively correlated, more or less, which are visualized by the red colors. However, on the right panel, you see some of the correlations are flipped, particularly customization activities on the left side of the panel, and the political efficacy on the right side of the panel seem negatively correlated with other variables. So these biases on the relationships might bias your regression results. So there are multiple ways of correcting this potential bias. One is traditional socio-demography-centric weighting. So the purpose of this weighting is to make the findings representative of the national population. The second method is something called inverse probability weighting, often abbreviated as IPW, which is essentially two-step estimation. In step one, you estimate the participants' donation propensity using the full data that includes donators and non-donators. And in step two, run the main regression you want to run with penalizing the donators who are likely to be overrepresented with the donation propensity that was estimated in step one. Let's move on to the next topic, inferring latent factors from sparse takeout data. The method that is proposed here is designed to overcome the information sparsity and small n, large p problems. This table visualizes the typical data you might see from the participants' Facebook user API. There are n research participants, and there are p pages they could potentially like. And the like is represented as 1 here, and the not like is 0 in this example data. So we have vector representations over user preference with discrete value 0 and 1. So suppose we are not throwing the data away, then we have following issues. First, nice statistical assumptions are broken. For example, number of rows, which is n, the number of users and participants, is smaller than number of columns, which is the number of keywords. And non-identifiability problem. So this is similar to rotation issue in the factor analysis. And fundamentally, probably many of these keywords are not of our interest, which means that we don't know what the first dimension of PCA means. For example, how do we know it is the liberal conservative dimension? So to overcome these problems, we propose augmented Bayesian factor model here, where user I is likely to like keyword J if the distance between user I's ideology, here the WI, and keyword J's ideology, here it is denoted as ZJ, is close enough. Okay, so what we observe is YIJ, okay, whether user I liked keyword J. Okay, using this data, we want to recover WI and GJ. So this is somewhat theoretically driven, but very similar to the user factor models, where from the observed data, you want to recover the factor loading. However, actually, we have additional information. We have prior knowledge about ideology that some keywords may represent. My question, motivation of this theory, this model is, why don't we use this prior knowledge if we are lacking information? Okay, so the Bayesian prior offers a natural way of incorporating our pre-existing knowledge. So we already have strong belief about the ideology of New York Times and or Elizabeth Warren, for example. So which means that we know the value of some of ZJ here. Using this techniques, identifiability issue may be resolved because we fix some of the latent variables on the certain value. So in confirmatory factor analysis, identifiability issue is often resolved if you restrict your model to the enough level. So this is very similar idea. And also the strong prior, which we know is indeed ideological scale ex ante, forces the latent dimension to be also ideological. So the question of how do we know actually the estimated latent factor is ideology dimension or not is actually resolved using this technique. So these are the directions we are heading right now. In terms of the weighting method, we're trying to find a better prediction for the donation propensity. So we're trying to adopt machine learning type of approaches with nonlinear models and automatic model selection using regularization. And in terms of, when it comes to the inference of latent factors from choice data or Facebook takeout data, the ultimate goal we are trying to pursue is comparing factors, latent factors from user choice with latent factor from the algorithm's categorization to see the bias of the algorithm. So to do that, we have to make our algorithm more accurate, or estimation more accurate. So to do that, we are trying to unweight the estimated latent factor with little information by adopting the technique called regularization here. Most importantly, after we finish developing all the estimation method, we're trying to open source the method via open platforms such as GitHub as a package to make the methods widely adoptable. And that will truly lower the bar of using this and take out the data, which is weird, ugly, but very, very valuable source of data.